Hello. Now today we're going to look at the idea of rates of change. Now really we've been looking at rates of change for ages now. That's really what differentiation gives us, how one thing is changing relative to another. But we're going to put specific emphasis particularly on distance, speed and acceleration. So a physical example of how rates of change relate to each other. And we're also going to look at more wordy type questions related to rates of change. So no new maths here really at all, just some new ideas and some refreshing on some language that we would have dealt with in some algebra problems a ways back. Now, a reminder that, to mention, rate of change, if you're not given any further context, if it just asks you for the rate of change in a physical type situation, it will often mean dy dt. It will often mean instead of getting dy dx, you'll be getting dy dt. So how is something changing in time? So how quickly is something changing in time is often what rate of change will mean. But that is not a universal. It's just if they don't give you any further context, it will often mean how does one variable change relative to time. Now, an example of this, which is a very important example, which has lots of language associated with it that we're going to go into in a moment, is distance, speed, and acceleration, or using more Leaving Cert maths type language, displacement distance will be given as S. In junior cycle, we would have used D for distance. Here we're going to use S technically for displacement. For all practical purposes in Leaving Cert higher level maths, you can think of displacement and distance from a point being the same thing. So displacement is distance from a point in a given direction. But in almost all cases, displacement will just be what you would normally think of as distance. So you don't need to get too hung up on it. There is technically a difference that we would go into more in physics or applied maths. We don't need to worry about it hugely in Leaving Cert higher level. But if you are familiar with physics or applied maths, there's nothing different here. The same general principles apply as would apply in that context. Velocity is another word that will be used for speed. Again, it has a slightly different meaning than speed for higher level maths. We don't worry about that. Whatever intuition you have for what speed means will also be true for velocity. And acceleration, likewise, just means how quickly our velocity is changing. So let's look at how this relates to derivatives. If we start out with a displacement of s, our velocity or our speed, which we'll call v, would be how quickly our displacement, our distance, is changing with respect to time. We would have seen this as speed is equal to distance divided by time in junior cycle. Here we have a more advanced version of it. So the instantaneous speed is equal to the instantaneous displacement over the instantaneous time. So this is our concept, and is there anything else to be said on that? Not really. So our velocity is equal to our derivative of our distance with respect to time. So we have to know by heart that velocity is ds dt. Now, acceleration is how quickly our speed is changing with time, or velocity is changing with respect to time. And if we look at the relationships here, we can see that it must also be the second derivative of the displacement. So if we are asked for the acceleration and we know the distance of the displacement, we automatically know that we can get the acceleration by taking the derivative twice. So the derivative of distance with respect to time is the acceleration, and we need to know that relationship as well by heart. And finally, a bit of a reminder on more general English that I alluded to already. dy dx means the rate of change of y as x changes. So how does y change as x changes? And dA dr would be another example. This could mean lots of different physical situations, but it could mean the rate of change of area, A, as the radius changes. Say if we're dealing with a circle, how does the area of the circle change as the radius changes? So that's what dA dr could mean. And we need to get more comfortable now with having different functions and different variables that we're getting derivatives of. So let's look at this type of physical situation here. A ball is thrown upward. So we've thrown a ball up into the air. And we can do this if it's safe to do so with your pen or with your rubber, and we'll see the way that it moves. Its height in meters is given by s. So s is often our distance or our displacement measurement, is equal to 15t minus 5t squared. Those of you who do physics or applied maths will recognize this as s is equal to ut plus a half at squared. T given in seconds. If you don't recognize that, don't worry about it. You don't have to. Part 1, find its initial speed. Now, initial is a keyword that we have to know in lots of different Englishy type questions, and it means, I'm going to make a note to myself here, that means t is equal to 0. So what is my speed when t is equal to 0? So initial, I'm underlining a key phrase, means t is equal to 0. Time is equal to 0 for the initial situation. So initial condition means time is equal to 0. Then I'm looking for, in part 2, the maximum height. We're going to come to what that means in a minute, then acceleration, then the speed after the first second. So let's get into part 1 first. So the initial speed, let's translate that into mathematical language. That means I'm looking for ds dt. So my velocity, or my ds dt, when t is equal to 0. So I need to find my velocity and then set t equal to 0. So let's do that. I have s is equal to 15t minus 5t squared. I get my derivative to get my velocity or my speed. Again, those two words are interchangeable in our system. 15 minus 10 t. Set t equals to 0, which we could also write as v of 0, would be the same as ds dt at t equals to 0. It's important we can know these different ways that they could give us this information. And we have 15 minus 10 on 0 is equal to 15. And what's our units here? We're in meters and seconds. So we have meters per second. That's our velocity when time is equal to 0, or speed when time is equal to 0. So that's my part 1. Part 2. I'm asked for my maximum height. Now, maximum, immediately I'm thinking a derivative is equal to 0. Now, that's what, when I see the word maximum, I'm thinking of the derivative equals 0. In this case, it's going to be ds dt equals 0. Maximum or minimum happening when ds dt equals 0, and d2s dt squared is going to be negative for a maximum. But beyond that, I can also give myself a visual interpretation of this. I can draw in a sketch. Again, drawing these sketches in now improves my intuition. So I'm looking for my velocity. No, I'm not. I am looking for maximum height would be my height is given by s, and time is changing. So I have a negative quadratic, so I have a frowny face, and I have my object flies off, is thrown up, and then falls back down to Earth as time passes. So this is not a distance measurement here. We could say the pen goes, or the ball goes straight up and down, but time is progressing to the right. So we are looking for the maximum height. We're looking for this height here. So let's see if we can find our maximum height. So I have s. So that is going to happen when ds dt is equal to 0. So ds dt, I already found, is equal to 15 minus 10t, and I want to know what that is, and that equals 0. When I rearrange that, I will get t is equal to 1.5 seconds. And I want to be sure that that is a maximum height, not a minimum height, so I shouldn't be going in assuming that it is a maximum, so I have to get my d2s dt squared to double check. My d2s dt squared is just going to be minus 10, so my d2s dt squared when t is equal to 1.5 is going to be minus 10. That's less than 0, therefore a maximum. So I know I have a maximum. I have to do that test. And then I need to find out what the height is at that point. So I have s is equal to 15, or s when t is 1.5. Is equal to 15 on 1.5 minus 5 on 1.5 squared equals 11.25 meters. So that is my maximum height. What is my acceleration? Well, my acceleration is just equal to d2s dt squared, or it's equal to dv dt. I need to know that it's both, how my velocity is changing or the second derivative of my distance. In either case, I already found that it is equal to minus 10. Meters per second squared is how we write acceleration. And finally, IV, the speed after the first second. How do we translate that into... we're looking for v1. So what is the speed when t is 1? Or we could write that as the SDT at t is equal to 1. We know what the SDT is equal to, so let's just sub that in. So we have 15 minus 10 on 1 is equal to 5 meters per second. And that is what we need for our rates of change. So again, we need to know these relationships by heart. Velocity or speed is equal to the rate of change of distance with respect to time, and the acceleration of something is equal to the rate of change of velocity with respect to time, or the second derivative of the distance with respect to time, or displacement with respect to time. And that is what we need for now.